Okay.
Nice place.
Yes, sir.
So I was curious, is the inauguration is along with all FDPs or just inauguration only for you, sir?
There is an inauguration in the starting itself. Then only technical sessions will going on.
Oh, I see. So it's not a central inauguration from the FDP, it's just inauguration from your side, right?
Yes, sir. Yes, sir. Actually, central inauguration from AICT has been already done for these FDPs.
Oh, I see.
Yes, sir.
Okay.
Hello. Hello. Naman.
Yes, sir.
Okay, you can hear me?
I can hear you, sir. Yes. Yes, sir. I can hear you.
Okay.
We are just going to start in a while, so kindly bear with us. So good morning to all of you. So on behalf of Institute of Engineering Technology, Agra, I, Namangar, I would like to welcome you all in this 5 days ATAL FDP on Internet of Things sponsored by AICT. So before starting the program, I would like to take blessings from by calling Ma Saraswati. So we will do some Saraswati Vandana.
या कुन्देन्दु तुषारहार धवला या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करः प्रभृतिभिर् देवै सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचार सार परमा आद्यां जगद्व्यापिनी हस्ते स्फाटिकमालिकां विदधति पद्मासने संस्थितां वन्दे तां परमेश्वरी भगवती बुद्धिप्रदां शारदाम्.
So thank you very much. So now I would like to call Director of the Institute of Engineering Technology, Professor V.K. Sarso sir, for welcome note, and also he's the coordinator of this FDP. So V.K. Sarso sir.
Thank you, Namanji. Respected Professor Ajay Taneja, Director IQAC of Dr. Bhimrao Ambedkar University, Agra. Today's eminent speakers, Professor Shivakumar Matapathi, Engineer Bharat Kumar, and Engineer Krishna Mohan Patel. Professor Manu Pratap Singh, Head Department of Electronics and Communication. Professor Manoj Upadhyay, Head Department of Mechanical Engineering. Dr. S.K. Jain, Head Department of Computer Science Engineering. Dr. Naman Garg, Coordinator of this FDP. All dear participants, ladies and gentlemen. Very good morning to one and all present here, and thank you for joining us today for this 5 days faculty development program on IoT. I would like to welcome with deep sense of gratitude the team of eminent speakers, Professor Shivakumar Matapathi, Engineer Bharat Kumar, and Engineer Krishna Mohan Patel for giving their valuable time and will deliver their knowledge to the participants in the field of Internet of Things. I heartily welcome to Professor Ajay Taneja, Professor Manu Pratap Singh ji, Professor Manoj Upadhyay ji, Dr. S.K. Jain for joining and motivated the faculty members to organize this program. I would also like to welcome all the faculty members and research scholars for participating in this faculty development program. As we know, IoT is dramatically changing the way the world consumes content online and offline. The influence of IoT technology on society and human being has been strong. The number of applications of IoT is increasing and the IoT research field is expanding. The application of IoT range from agriculture, space to underwater exploration. In this direction, IIT Agra is intended to organize AICT training and learning program for faculty development sponsored by AICT on Internet of Things from 12th to 16th October 2020. The idea of this FDP is to make the participants aware of the IoT field. The FDP will comprise of the essential theory with hands-on experiment on different simulation software by the experts from academic and industry to improve the understanding of this highly technical field. I am sure this will improve the quality of the teaching, which will motivate the student to take up the challenges in this interdisciplinary field. I wish this FDP will successful and reach its goal. I again welcome to all joining with us. Thank you very much. Namanji.
Thank you very much, sir, for your kind words. So now I would like to call Head Department of Electronics and Communication Engineering, Professor Manu Pratap Singh, sir, for giving a brief about this FDP on Internet of Things. Manu Pratap, sir.
Thank you, Engineer Naman Garg ji. Respected Professor V.K. Saraswat sir, Director IIT Coordinator Techie Program. Respected Professor Ajay Taneja sir, all the eminent speakers, all the participants. The topic which the Institute has selected for the FDP, this is the IoT. And it is the field where all the disciplines are emerging. If you just see the scenario of the world, and it is a true picture of the world that in 1 minute, we are emerging billions of data through our social media. Through email, through WhatsApp and the other media, we are emerging the uncountable amount of data in 1 minute. the big question in front of the scientist and analysis, that how to analyze the data. So now from here, the starting of the point of IoT starts. So now to analyze the large amount of data, to keep the data in the storage and connect the things from the things, a field is required, and we are just knowing that field with the Internet of Things. The sensors, the devices, and the various instruments, including the home appliances, the cars, the offices, all the things are connected to the things. It was the age of IoT. It means that Internet of People. Now the scenario has been changed, and now this is the age of IoT. The things is connecting with the things. So if we are talking about the things, it means that it may be the living thing or it may be the non-living thing, then these things are connected. The question is in the front of the computer scientist or the analysis is that how to analyze the data. So for it, a new word is also emerged with the IoT, and it is a part of the IoT. This is the AOE. It means that AOE and the IoT, this is a complete word which is providing a big picture in front of the community, and that AOE is the artificial intelligence of everything. So it means that to use the artificial intelligence, we are able to extract the useful information from the large amount of data. And it is a true picture that under the umbrella of artificial intelligence, the IoT, the cloud computing, all are existing. So now a big picture in front of the people, a big picture in front of the scientists, and the question is the ability to handle the data and in terms of the knowledge management also. So it is a scenario where the intelligence is integrated part of the Internet of Things. So I think that the immediate speakers, those are present here, will provide you the insight of this IoT, and I am hoping that this FDP will provide the new generation, the new scholars say, new light in the field of IoT. This word, I complete my speech. Thank you.
Thank you very much, sir. Thank you very much for explaining and for telling the importance of this Internet of Things. So now I would like to call Professor Ajay Taneja, sir, Director IQAC Cell, Dr. B.R. Ambedkar University, Agra. Professor Ajay Taneja, sir.
Thank you, Naman. First of all, let me welcome you all to this one-week online faculty development program on Internet of Things, which is being conducted by Department of Electronics and Communication Engineering, IIT, Dr. Bhimrao Ambedkar University, Agra. Let me first start with congratulating the patron of this FDP, our Honorable Vice Chancellor, Professor Ashok Mittal, Program Chair, Professor V.K. Saraswat, the Director, IIT, the Program Co-Chairs, Professor M.P. Singh, Professor M.K. Upadhyay, and Dr. Sandeep Jain, and Technical Program Committee headed by Engineer Naman Garg for taking such initiatives so that our faculty as well as neighborhood institutes faculty benefit from it. As already spoken about IoT by Professor V.K. Saraswat and Manu Pratap Singh, let me add few things. IoT is developing quickly and becoming an increasingly growing topic that creates excitement and anxiety around the world. There are plenty of indications showing that IoT will change many sectors, including higher education institutions, especially universities. So now university has an opportunity to lead this technical development and innovation models for the IoT and to build the leaders of IoT into the future. So that the factors like TIPS, which stands for trust, identity, privacy, protection, safety, and security related to the IoT is expressed. Thus, IoT not only enables connectivity for anyone and for anyone to be networked around the world, anytime and anywhere using any network or any service, but also to achieve the goal of intelligent identifying, tracking, and managing things. It is an extension and expansion of internet-based network which expands the communication between human to human, human to things, and things to things. IoT finds application in almost all the disciplines like smart homes, energy management, transportation, even environmental monitoring, agriculture, waste management. I think it is everywhere and it will be everywhere in future. IoT will change dramatically the way university works and enhance student learning in many disciplines and at any level. It has a huge potential for universities or any other educational institutions if well prepared to ensure widespread and successful implementation by leadership, staff, and students. That is why we are conducting this FDP, and I hope all our delegates will benefit from this FDP because we have a galaxy of speakers like Professor Shivakumar Matapathi, Mr. Bharat Kumar Alam, and Mr. Krishan Mohan Patel, as well as for tomorrow we have Professor D.N. Sonwane and Dr. Sanjeev Yadav. So all they will be speaking and telling you about the different aspects of Internet of Things. I think everybody will benefit from that, and all the best from my side. And I also express my gratitude to the organizers for calling me and giving me an opportunity to speak few lines. Thank you very much.
Thank you very much, sir, for your word of wisdom and further elaborating the term Internet of Things. Thank you very much, sir. So now I would like to invite the technical expert for today's session, the eminent speaker, Professor Shivakumar Matapathi. And first, I would like to introduce him. Professor Shivakumar Matapathi is an adjunct faculty member at multiple universities, including the University of California, San Diego Extension, Santa Clara University, and he's also teaching at regional community academia, including ethnically diverse institutions such as Olon and D&J College in California. Professor Matapathi has been a passionate educator for nearly 25 years of industry experience with a strong desire to help faculty, research scholars in recognizing the connection between learning and industry needs. He is an accomplished researcher and a co-founder of DU Mobility Incorporated and Extrans Solutions Private Limited. His teaching and research areas include the Internet of Things, machine learning, artificial intelligence, cybersecurity, and blockchain. He has also authored numerous articles published in prestigious journals, including IEEE and various conferences such as NIST, Smart City projects. He is the co-founder of Extrans, which is a leading company in establishing Center of Excellence to assist higher education to educate their students about the next generation internet research and development programs. Professor Matapathi is also a team lead of the education cluster at the Global City Team Challenge project in collaboration with the National Institute of Standards and Technology, NIST, under the US Department of Commerce. He is the key contributor in creating tutorials, workshop, and practice use cases for smart cities. The workshop also discusses about IoT standards and a protocol which would help community partners and municipality staff to get familiar with national as well as international IoT standards. Professor Matapathi receives his MS degree in technology and innovation management from North Central University, California. So we welcome you, sir.
Thank you so much for the kind introductions, Dr. Garg. Good morning, everyone. Honorable guests and speakers, as well the delegates today. Professor V.K. Saraswatji and Professor Ajay Taneja sir, and Professor Manu Pratap Singh, and Dr. Naman Garg, and all the delegates, research scholars, and attendees. Good morning, everyone. It is my pleasure to be here, along with my colleagues Bharat and Kishan, who are online. So it gives me an immense pleasure to share, our experiences, what we have been teaching and what we have been learning at California. I know when my colleague Kishan sent small word about ourselves to Professor V.K. Saraswatji, he was kind enough to consider our proposal, saying that okay, why don't you come here and share your experiences on that. And also thanks to Professor Ajay Taneja sir for giving his thoughts. He really put a very good point. I like the one word, I like the tips, which is more on a security aspect point of it. Definitely I learned that word today. And also many speakers, they talk about it very briefly, what the IoT importance is and what are the applications we can talk about it. So again, congratulations once again to Institute of Engineering and Technologies, Dr. B.R. Ambedkar University, for doing an incredible job, because getting an AICT, I know I'm in touch with the AICT coordinator very on weekly basis. I've been talking to them for some of the high initiative, how we can include the IoT, machine learning, blockchain for the new education policy. I've been discussing with them. I know they've been telling that it's a tremendous competitions even to getting this AICT, FDP program. You all got it. It's a congratulations. It's the first step that this institute has got it. It's my sincere congratulations for that. So today I am here. My team is here to talk about the IoT. And good thing is that we have given an ample amount of opportunities to talk from fundamentals, then connectivity part and the cloud, and then go on to the real virtual lab. So we will be, hopefully, it will be useful, very useful, because when we have only 1 or 2 sessions, probably we may not be able to cover up everything. So today objective is, how we can take our learning IoT to the, lab session. So that's what we come, because we want to be more practical as possible. Theory, anyone can get it from the internet, but our goal is to make it, as practical as possible. So please bear with me. Then what I will do, that we will go through the stuff, and then my colleagues in the later second stage, they will really show it. I will also try to demonstrate a few, few of the hardware, software, and the connectivity. So let's deep dive into the, the program. So please allow me to share the screen. I think I should be able to share my screen here. So hopefully I should be able to get that one. So so this is the today's topic. Again, thank you again, kind introductions. Again, I have a big title, but please call me as a Shiva because it's a long name. As long as it comes on my credit card, that's okay. I was happy, because when I came here to US in 2001, even credit card company was saying, oh, your name is so long, we cannot put everything into your credit card. They said we want to shorten it. Okay, sir, whatever you want to shorten, as long as I can use my credit card, that's fine. So please call me as Shiva. So I'm the adjunct faculty, like you said. I'm not a full-time faculty. I actually come from an industry background and then moved on to teaching for last 5 years. So let's see here. So let's go on to the today's topic is, I'll give a little fundamentals. So good thing is that all the time we get a slot in the second or third or second day. At least most of them will be covering up. The good thing is that I can cover up really as basic as possible and try to build the steps on that, so that my colleagues can patch up in the thing. So let's see, let's start with a very, very basic definition of IoT, So, if you really talk to various people coming from, computer science background, computer engineering, electronic engineering, electrical engineering, or mechanical engineering, everyone has got a different perspective of defining the IoT, right? If you ask an electronics engineers or electrical engineers or communication engineers, they say IoT is relevant to the embedded systems, right? Because we all know that last 30 years, coming from by the way, my undergraduate is electronics background, and then I moved on to computer science and the innovations, my master's. But if you really look into the electronics engineer, the IoT was there. Basically they were connecting all the sensors, actuators to the microcontroller, 8-bit microcontroller. We started with the 4-bit microcontroller, 8-bit microcontroller, now moved on to 16-bit. 32-bit also we can do it, but it is not necessary, right? So they will say that, okay, my sensors are connecting to the microcontroller. That's their IoT definition. If you ask a computer science or a computer engineers graduates, they say that no, IoT is everything coming to the cloud. As long as the information comes to the cloud, that's this thing. I don't care about the sensors. I don't care about the actuators, right? They want to be in a computer science. If you ask a data science engineer or a data scientist, they will say that no, we don't know the connections, we don't know the sensors. As long as I see my data, visualizations, as long as my data popped up to the required information by the stakeholders, it could be at the director level or HOD level, or at the VP level, or at the president level, right? So they need to show them a real visualizations, nice visualizations. There are a lot of visualization software has come. We are going to cover up, for example, Microsoft Azure, then you have got Amazon Web Services, ThinkSpeak. We'll demonstrate it, all those things, So then different people have got a different definitions. But I picked up from an IEEE definitions, what the IoT is there, which is an unbiased IoT. So it actually talks about everything there, right? It interconnect all things, including everyday and industrial objects. Like earlier speaker in the inauguration, they talk about it. It's very right, it's everywhere, Professor Saraswat mentioned that, IoT is is going to be a very emerging. All the students will get benefited, all the things benefited. That is very true. Even the, Professor Ajay Tanej also mentioned that, to certain extent, we have Professor Manu Pratap Singh also, he mentioned about how all the components are getting merged into that. Yes, this is actually, if you really see this 5-6 lines, you will see, all the, components in that. It's industrial objects, and it makes in, very importantly, intelligent, programmable, and more capable of interfacing with humans. This is very important, right? It is intelligent. It has to be, it cannot be just a dumb terminal. It has to be an intelligent. It has to at least process something, and it has to be programmable. I should be able to program it, whether remotely, on site, on the fly, from there, I should be able to program it, and more capable of interacting with the humans, because ultimately, whatever system you design, whether it's a supercomputer or a desktop or a laptop or a smartphone, it has to communicate to the human beings, right? Because they're the one who making the decision, whether input, whatever the output you are showing them, So you have to work with the human. So that is why, this IoT is such a concept, the IEEE has defined that it is a combination of everything. And final goal is that we have to communicate to the human being on that. So this is IEEE definitions. If you want to more definitions, you can visit this IEEE IoT towards Internet IoT. So you will have the correct definition of IoT. Now then we'll see. So now, what is enabling for us? This is okay. Before that, let me go into market terminology here. Basically, like I was telling, IoT was there since from probably, I would say 30-35 years of embedded electronics. But there was a Kevin Ostham from MIT in Boston. He coined this word Internet of Things. Basically when he invented, or he actually found it, RFID, simple RFID technology. He was connecting to open a door, and then it connected to his PC through a simple Ethernet, because that time internet was there, but it was only for the military, right? If you really see the internet, it was for the DARPA, what we call in the US military. They used to have, many of you know that it used to be only for the Unix based machines. UC Berkeley University. I had a chance to visit the whole UC, where the Unix was born. So it's very interesting. They had a big mainframes, and then this IBM 370. Then you have got a PDP 11. So everything is there. They put it there. That is where the Unix was there, and then they introduced that. So it used to be Unix-based internet, right? We used to have a shell and then open it up, and then you used to send. I think many of you, if you worked on some of the old. So then he actually connected a device through an Ethernet, and then he thought, oh, this is actually connecting that. And top of it, in Stanford University, one of the scientists again, what they have done is they have connected their bread toaster, basically they were working on something and they've connected a bread toaster and then, they connected a bread toaster output of their bread toaster to a machine. And then they used to go to the Xerox machine, because now everything is Xerox is not there, Xerox machine. So whenever they go to the Xerox machine, they take, they want to take the copies. At the same time, they want to get a message that my bread is over, toaster is over, because, here everybody is running. It's now it's become global. At least in India, we have to have some time. But here everybody is changing the time. So they used to keep the bread toaster, and then you go to the Xerox machine, and then whenever the bread toaster is done, you used to get some small email through an Ethernet, Oh, then he said that is the thing, bread toaster is also a thing. And then, everybody started inventing more on that. So from then they all invented, and now we are into 7 billion IoT devices, it's, in 2018 and 19, we are talking about the 26.6 billion, see, basically, if you really look into the growth, it's going tremendous, when you have a 7.3 billion people. Now today we're talking about a 26.66 billion, right? It's almost, at least 3 to 5 devices per person. It is possible, right? I mean, when I saw this number, why is it possible? So many devices are there. We need so much of software, so much of microcontroller, and so much of memory processing, and then send it to the cloud. Then yes, it is true. If you really see our own case, if you really look into the devices, I was counting devices, number of devices at my own home, right? I have about 12 connected devices, right? Including the laptop, all the family laptop, then your smartphone, they're all devices, right? Smart devices, then your TV is connected to the internet, then your refrigerator is connected to the internet, your security systems, home security system is connected to the internet, car garage, it's connected to the internet. Then you have washing machine, then your, the dishwasher, everything is kind of in some other way it is connected, whether it is a internet, whether it is a Bluetooth, or it is a Zigbee, some other way it is connected. So at least if you see 3 to 4 devices, each one will be carrying it, 1 or 2 phone devices and 1 desktop at least, right? So definitely it is possible. And the other statistic says every second we have 127 new IoT devices are connected, So that's actually a statistics given by United Nations, one of the conference they have announced this. And during 2020, expert estimate that 31 billion. That is true. Actually, it happened in 2020 because of this COVID pandemic. It's little bit how it might step down, but on the technology front, COVID has not affected, it is actually increased the work, if you really see in Silicon Valley, I'm sure that same thing in India, that all the technical people, everybody is occupied with their own, this thing. In fact, work is double, double or 3 times, right? So that is happening. Now, how do we address this? Let's go on to the little technical on this now. So this is, about the enabling technologies. What are the different aspects into that, right? You have internet protocols. I mean, in how the IoT, what are the opportunities or enabling technologies we have? We have sensor technologies, then you have embedded systems, artificial intelligence, cloud technologies, all those things are coming up now. So I have one slide here. This is about the different applications. Already speaker have talked about it. So we have, security, security and surveillance, transportation, then industrial IoT is going big time actually. This afternoon I was talking to a Microsoft vice president. He's my close friend. So he was saying that Microsoft has come with a virtual reality. In fact, he's offering me, which is he's come out with a new virtual reality where they provide the glasses to the technician and the service engineers. So they go to the field, or you can log into remotely any of your machines. They can really solve the problem remotely there. So virtual reality, they can log into those aspects, and then they will go, and they're giving the software free. I need to research that. I didn't had a chance. He said, why don't you implement that in the educational institutions? Because they're saying that any teaching, because under this pandemic, Microsoft has come out with a virtual reality. I think they have termed virtual reality into the other aspects, and they're coming out with a little hardware. but hardware is little expensive. It's a special glass. You have to wear that. There's also an IoT device, right? You have to wear that virtual reality glass and then connect that glasses to your any equipment. For example, I'll just take a basic example. Suppose if you have a server, big server, right? Or you have take a TV receiver, a smart TV is there. Now you want to repair it, of course, things are not beyond the repairable. Now, it's everything is working satisfactorily because most of them are designed very nicely. I remember then, when earlier days when we had a, color TV, the failure rate used to be more there, right? Now everything is improved because there is a system on chip has come, or, all the devices have been stabilized. But, still I'm just giving that example, that example, or any industry machine, if you want to repair, then remotely you can log in through that virtual reality machine. And then, you can see that. So Microsoft is supporting heavily onto that. So retail is another one. Any retail shop you take, the IoT is going big time. One of the example is that, Amazon has got a store, in Seattle and in San Francisco. I'm sure it is there. I heard in some of the cities also coming up in Bangalore, where it is, there are no the desk there at all. There is no accountant. There is no person who's scanning your item. Everything is retail. Everything is automatically done. When you walk into the showroom, they just know that who person entered and what item you took and what is your credit card number, and immediately they send you that. There's no human interaction at all there. Healthcare, big time is going in IoT. Healthcare is going in a big time. Lot of sensors we are getting it in the healthcare. It could be your blood pressure, or it could be your heart rate monitor, or it could be, they call it as a well-being. The new concept has come is a well-being. Instead of you going to, or one going to suppose I don't have to go to a doctor, right? I have a device, then it will monitor my vital things and tell me that, okay, from the cloud, that what are the aspects, I should be taking care, what are the health vital parameters, it will checks my blood pressure, it checks my, heart rate, and it also checks my, glucose, whatever you want, you can name it. So there are sensors have come because they evolved, and we talk about it. Few examples, consumer and home, it's already there. Anything, you connect it, like we talked about, right? All your apertures, home apertures are connected to the internet. A smart infrastructure, yes, a smart city, which I think, in my that intro, we talked about it, right? A smart city from the NIST. So I'm the part of it. If time permits, in one of there, I will also talk about the smart city. There one session is there, but only timing we need to work it out. But I'll share with my colleagues. They will be able to share that what smart city we are doing it. Security and surveillance. So we talked about it, right? For example, here, we have cameras, and then all the sensor connected to about 13 windows here. So we can really, know that, if somebody's break opening, then it's IoT, and you can store the data somewhere in the cloud, and somebody is monitoring in the cloud. Anything abnormal happens, you get a call, or you get some kind of an alarm, or, you take a picture, and so really it is becoming a very, very, useful tool. And for the COVID also, it's for the pandemic COVID, it's an unfortunate situation. Lot of devices are coming up with IoT enabled. For example, your social distancing, your entry to any building, it has to cross check your, whether you're an authorized person. It will take the temperature, and it will also check whether you're wearing the mask or no. So then only it will, enter into these things. And then of course the sanitize, whether you're sanitized or not sanitized. So all those data, you can monitor on that. So that's about this thing. Now let's see. So this is based on our experience, how the IoT is, moving, in the direction of requirement from the industry, from the city. When I say city, it could be, it could be, your district commissioner office, or it could be, municipality office, or it could be in the state level or a central level, right? So if you see there, this is your IoT devices. So these are your IoT devices here. And now we'll talk about it. Now IoT devices are moving the data to the cloud here. There are different clouds, like I talked about it, right? I think in few slides are there. We come about it. This is a cloud, and we push the data to the cloud. And once it comes to the cloud, then you have got different analytics, right? I got the environmental monitoring. I have the health monitoring. I have we talked about the retail. All those data are available in the data analytics. So once you have the data, we have the machine learning, right? We said that, okay, machine, we are training the machine that you take this data and then you provide the, output for us, So instead of we punch in every time or we want to ask any details, learn that. And then we have an artificial intelligence, right? So you take the data to the, from this sensor, and then machine, you're training the machine, and then artificial intelligence will be able to provide you the output. Now from here, you are taking it to the, now it has to be feedback, right? I mean, there has to be feedback. What it goes in the input, it has to give on the feedback to the input, then only the cycle completed, right? I mean, as per the, if you see the natural law, whatever is there, if you are serving these inputs, the natural law says that you need to get back some feedback, right? I mean, you need to operate it, right? So that's what it's again based on our feeling. Then we have the robotics, that basically it will operate all these back, right? So it will come back here, right? So it will come back and operate. One example is that I can use that, I come from an, again, manufacturing. If you see the PCB manufacturing, printed circuit board, you have the components coming from different vendor, and you have a printed circuit board. You put all the board. I mean, typically what we do in a lab, you get a PCB and then you solder it, and then somebody will clean that PCB, and then you will give it for a testing. They test it and they put the system, and then build a system integration, right? That's a normal way we follow up, in any thing. But if you see an automated process, components, it automatically, you give them the bill of material, what we call. So you give them the component, automatically it procure the component, it goes to the pick and place. There's robotic machines, which basically it will pick the components and place it there. And once it places, there's a wave soldering, what they call. Again, I may be giving the example on the PCB manufacturing because I come from the background, but you can implement it anywhere. It could be a mechanical engineers, or it could be a pneumatic, or it could be or any hydraulic systems, and you can use the IoT there. So you wave soldering it. Wave solder is also an automated process, and then you clean it. The PCB has to be clean, because there are a lot of soldering flux or the lot of the undesired items may be sitting there. When you wave solder it, you have to clean it, and then you have to test it, with an oscilloscope or your generator, frequency generator. You have to test it whether it gives the output, and then you system integrate it, because there's so many PCBs are there. Everything you integrate it. So this one is actually an IoT device. Now I don't have to do sitting over there, right? I can do it remotely. In fact, we are just 3 months away for introducing a smart manufacturing course in one of the university, Olani College, that already National Science Foundation has given us the grant that we installed that machine. We would be teaching it online. It's going to be first time smart manufacturing. We'll be teaching it online, because already in here, US, the next semester also they announced that we are going to have an distance learning only. Nobody is allowed to go to the university or the college. So we are trying it out. Last 2 weeks back, we have been trying hard, going there and learning ourselves first, and then coming back and then logging in remotely. So we'll see how it goes. Hopefully, if I get an opportunity next time, I can explain how remotely I am operating the manufacturing equipment. That is all surface mount technology, is your mechanical. So what I'm saying is that circle is completing with this whole help of this one. So let's see, go on to the little basics. What are the different components of IoT, right? What it makes an IoT. See, we talked about what the definitions, what the market, how it is evolved, and how the IoT can take it to the next step. We talked about the 4 or 5 building blocks. Now let's deep dive. Today, this week topic is on the IoT. Let's deep dive onto the IoT block diagram, right? So we have these are the 4 components you will see. Any IoT you take, you take your industrial IoT, you take home appliances, or you can take your health IoT, or you can take the smart city. These are the 4 building blocks. You will see that this is a basic block diagram here. So here we have a sensors. Then I have a microcontroller unit here. Then you know that microcontroller unit, you are connecting it to the gateways, which is got the it could be your, I'll come on the gateways, and then the applications. So as long as IoT is concerned at the university premises, just take example of you are monitoring a temperature and the humidity, or I would just give example is the air quality. You want to measure the air quality and temperature and humidity in Agra city. I'm just giving an example. Okay, and I want to monitor that one so that all the manufacturing industry, they are not really generating and polluting the beauty of that seventh wonder there, right, in Agra, right? So we're not wondering. So I want to monitor the air quality, or I want to monitor the pollution on that. So as an university, what you can do is that you can basically, you can have the sensor up to here, right? Your job is up to here. So this is your sensors. You decide on the sensor. We come back on the sensors. We have air quality sensors, we have pollution sensors, you have your water sensors. We talk about what are different sensors are there, right? So here we have the sensors, and then we have the microcontroller here, right? Here we have a microcontroller, and then the gateway here. So you can connect this one through different connections, right? It could be your Wi-Fi, it could be your Bluetooth, or it could be your Zigbee, or it could be your, now the LoRa has come, which is a narrowband, part of narrowband IoT. So we talk about it very little on this subject. So gateway, you can connect, because you have to connect it to the cloud here, right? This is your cloud here, right? This is the cloud. So you are connecting sensor through this microcontroller unit, because we don't need a CPU, heavy duty CPU there, right? I mean, if you're really coming from an electronic background, that CPUs are, they have got multi processing going on there. Then you have got so many cycles you need, and so much of memory you need. We don't need it, because these sensors are a 2-wire or a 3-wire. We are connecting a very simple 4-wire, maximum 4-wire, right? Even if you take transmit and receive path, you have 4-wire. Maximum 1 more wire you might add, just to keep it as a spare, or just to keep it as a shielded, right? Even if you want to send a shielded wire signal to the your, because of the distance, you might have the shielded, right? So you have the sensor, you have processor, and then you have the gateway, and then the applications. So once you come there, then you have the application there. So let's deep down into a little more, second level of diagram here, right? So here we have, different sensor here, I2C, UART, and SPI. Actually, I just want to, I don't know if it is possible here. I want to take a poll here. Let me try it out. If I can take the poll here. So it used to be there in my Zoom here. Let me see here. If I can take a poll here. Okay. So I want to just take a poll here. How many are from electrical, electronics, communication, telecommunication background? And let's split it in 2 ways. And how many are into computer engineering, and how many are from the other branch? I just want to understand that, so accordingly I can speak. I'm just trying to take a poll here. Let us make it a 3 group here, so that I know the audience there. Dr. Naman, can you able to help me? There is no poll here, right? I'm not able to see the poll here.
So we can just ask to write in the chat box. That will help for us.
Oh, okay. Sure. That is one possibility.
Yes, sir.
Yeah. Okay. So if you could kindly share, let me stop here. Share your, the which discipline you come from, so that I can accordingly fine tune my this thing, because I want to really make use of this time. So I'm getting some this things. Sorry, I'm not able to get the poll here, but chat is good. Like Dr. Garg said. Okay. So CSC background. Okay, EC background. Okay. That's an IT background. Okay. So we have a computer. Yeah. Electronics. Okay, good. All right. Okay. All right. Okay. Fantastic. Thank you. Thank you for your your message. That gives me a really good motivations to share my whatever I can do it from here. So it's electrical communications, then your computer science, computer engineering. That's good. More IT. That's good. All right. Okay. So you have a good background on this. Okay. So as people type in here, anyone got any question here so far? Am I going a little speed or pace is okay? Any question so far? As people are just typing it here, I can take one or two questions before I go to the next slides. All right, I know it's too early. Let me share, then probably you have I'll have opportunity to see questions. Okay. All right, so let me then go on. Okay, thank you, those who are this things. Any question? All right. So let's go on to the block diagram now, basic block diagram here. So so this is an IoT block diagram. You have that. So you have different sensors, like we talked about in the, I'm glad that, it's most of, are in the similar line of background. Thank you for, your input. So as you know that, most of, if you are, those who are from electronics and EC background, so you know that is an I2C, UART and SPA interface. Any sensor you connect it. I just shown a Raspberry Pi board. It could be any board that might be your simple, as long as it's got a microcontroller unit and accept I2C universal asynchronous receive transmitter and a serial peripheral interface to this, that is fine with me. I just shown a Raspberry Pi 3, but you can always use any microcontroller as well as this thing. And then of course we have a device driver software. Once you connect sensor to the Raspberry Pi, then you have a device driver software. You connect this sensor, and somebody has to really write the device driver software, or sometimes you also call it as the libraries. So it could be your embedded C, or it could be a Python programming, right? You just write the programming here and read those sensor value to this and make the timing diagram also, right? When the data has to be sent, when the data has to be received. So those aspects you can take there. And then you have an Wi-Fi here. This is a Raspberry Pi board as in Wi-Fi. I've shown as a Wi-Fi. You can connect it to any connections. It could be your Bluetooth, or it could be connected to your, Zigbee, or you can connect to LoRa. You need to have only that chipsets onto the board here. So then you have a protocol called MPQT. We come to that. We have one session, I think, or at least half of that. We talk about what the protocol is at MPQT and HTTP. We connect it, and then we just shown in UBA dot here. UBA dot is another cloud company. You can push the data to the cloud and then read the reading on that. So then you have of course, you have a Python, Node-RED, any Java programming. You can. So as far as again university or this thing concerned, you will be doing only this part, right? So so you'll be doing only this part, right? So you are responsible for this, right? So you connect the Wi-Fi, and then like I said, it could be temperature, your humidity, and air quality or pollution. You can monitor everything, and it's a very good case, right? In especially places like Agra, suppose I want to spin the pollution now, it's so much of industries are coming up. I know there was a lot of article was there. I was going through that, what kind of that particular challenges we had. So you can take that as an university project and connect it. I'm sure there are already some companies must be definitely monitoring it and then sending the data to the cloud. So you can connect those different pollution control, the sensor all over the places, and then collect the data and then get the graph on your device or on your mobile device or on your desktop, or you can now the data also you can get it on a watch, right? If you have a watch, connected watch, then you can connect it to a Bluetooth and just see the hourly basis, right? What is the data coming up on that? So this is the block diagram of an IoT. So again, we need sensors, we need a microcontroller, a connectivity, and a cloud. These are the 4 components we need a building component. Once we have this, on top of it, there is a software, right? Somebody has to write the software. Little soldering these days. I mean, the good thing about is most of the boards are on the site. You will on off the shelf. So you just get the board and then connect it there, right? Yeah. So this is IoT ecosystem, a closer look, and let's see how it looks like. So you have an edge connector. Actually, they call it as an edge connector. To me, still it is not an edge. Edge means it should be able to process. It should be able to store also data, right? We don't need a cloud connection that time. Raspberry Pi or the small microcontroller, no, there is not enough memory to store it. Of course, nowadays the new Raspberry Pi has got a good memory storage, but if you really see in general, I'm saying that because earlier when they designed any microcontroller unit, it is supposed to be just get the message or get the data, whatever sensor you are connecting, and then process it and time it, right? You have to send it, right? You cannot send the data when and you require it, right? So that's what is the whole concept of something there. And then you have a network connectivity layer here, and then the data, data center here. You can connect to the cloud. It could be your any data for that matter. So visualization, analytics, data center, app lab. So you have like that. There's so many components involved in that. And once you are in the cloud, you can have multiple output, right? It could be a smartphone, or you can have this settings, then you have your analytics, then you have different cloud flavor. So once you have in the cloud, through that MQTT or an HTTP protocol, for now you remember 2 protocols. One is when you're connecting your hardware to the microcontroller unit, we use it as that hardware protocols. You have this I2C, UART, or GPIO, right? To connect it to that. And then when you connect from the microcontroller to the cloud, we use the MQTT, right? We have the HTTP and MQTT. We will talk about it. What is MQTT and what is HTTP? Just hold on to that. 2 protocols you have to remember. Networking in another one subject is the TCP/IP in the background, because I'm getting the data, connecting to the microcontroller unit. Somebody is a transport layer or transport port, which is taking my data to the cloud there, right? So let's see on the bigger perspective of the data now. Let's see, go on to the real, what we can do it on that. So to argument all these concept, what we talked about it. So during teaching process, we learned that it is becoming really lot of work for the. It's good actually. I mean, students and the research scholar, they need to have the work. But let's see how we can focus on the software instead of you going to the market and getting all the components and all. So what we have done is we have just developed in common universal development platform. It's open source development platform. When I say open source, we have a Raspberry Pi and Arduino board. Both we have put it onto the board here. So let's be here. So as you can see, here we have the Raspberry Pi board, and then we have a Arduino board and all the connecting sensor. Let me change my pen color here. Let's take this pointer. right? So here I have a Arduino board, and then I have some switches. Then I have some LEDs. I have a lot of sensors on this, right? I have a proximity sensor. I have a gas sensor. I have a temperature sensor. I have a light sensor. Then I have some motor control over here. I'll show that board here, no? So this one is a very universal platform. You can also build it. It's not a rocket science. The only thing is someone has to really, go through that circuit, what connect what and when to connect it. So on that board, so we can put your IoT anywhere you're doing it. You remember that second or third slide we showed about that, right? AI powered, right? This is artificial intelligence and machine learning. We talked about it. That we have ported it. And blockchain. We have a virtual lab, thanks to the organizing committee that they have given us 2 more slot. Wish we could have got more so that we can really have some hands-on, right? Our goal is to make a hands-on session. No? People can really log in remotely. By the way, these are all, you can log in remotely. Virtually, you can log into our hardware, my hardware or my colleague's hardware. We have 2 locations over there, one in Bangalore, I think, one in Patna. So you can log into 3 different hardwares, my hardware, that one, this one. One more colleague would not join, this IIT Agartala, no? So he has got 1 board. So you can log into any of these board remotely. You don't need physically these boards through this virtual network computing, right? So once you log in here, then you get access to all these sensors, sensors, actuators, everything and all. And then the cloud, we have Amazon Web Services, Microsoft Azure, then you have IBM Watson, then we have created our own cloud, Expanse Cloud here, then Google Cloud. So it's really very, very robustic stuff, so I will show that this thing. So this is the actually a complete a development platform here. So let me just stop here, and maybe I'll just show one board here, and then we can move on to this one. So how it works, I'll just show that. Okay. So this is the board what we have, what it has been there. Like I was telling, so that basically you will get a chance to go into virtual lab there. So here, I don't know if it is shining there, but let me try it out. So you have a Raspberry Pi board, then you have a Arduino board, and these are the different sensors here. We have, for example, let me see here. Yeah, we have a proximity sensor here, gas sensor, temperature, light sensor, then moisture sensor. Then I have a Bluetooth enabled here. So the Bluetooth chip is there here, and then we have the 7-segment display, and then the LCD display. You can do that. It's basically then there's some switches, on-off switches here, and LEDs. So you can develop any IoT project on this whole platform here. No? So you don't have to really go to the market and get this stuff. So we will go on to the different hardwares available, right? So what I will do is that I will demonstrate some of the hardware available for you to demonstrate. This is a consolidated board, and then the software tools what is available. And then probably in my follow-on session, we talk about the standards, right? What are the standards? How do you connect it? And then we have a virtual lab in the afternoon. My colleague Kishan will show you the lab, right? He will really, you can log in remotely on that. So with that, I'll stop here. Any questions so far, sir? Yeah. Please provide slides after. Yes, we will provide the sessions. Yes. We will provide us sessions. Sure, sir. I think I'll share with the coordinator. We'll do that. Then any questions so far before we go on to the different hardware, software? Yeah, we'll provide the slides. Just wanting any questions so far? Anybody? We remember that 4 components, right? We talked all those 4 components in detail now. Right? Yeah. We provide the slides. Okay. So no question, no problem. Okay. Yeah. So now let's go on to the yeah. So let's move on to the next one. Is the Yeah, how gateway provides connections to the cloud? Yeah, that is a good question. How gateway provide a connection? Yeah, you need to configure it actually. When I have the cloud, so if I'm connecting to this board, for example, okay, you need to, if I have this board and I have a connection coming from my cloud, then what I'll do is that I need to configure it. This is like an IoT. This is like another like your modem you connected, right? You should, not modem. So yeah, modem only, right? So you have a network company who provides you the modem for our Wi-Fi, right? Not for the computer. I'm saying it for your Wi-Fi. They give you the modem, right? The modem you connect it, right? Like that. You need to configure this one. We'll show that in the virtual lab how we can connect this one. So this is once it become a cloud. Then once you connect as a gateway, so then everything is connected through this, right? So there is a little process is involved in that. As soon as your Raspberry Pi you power on, then there is a Wi-Fi connectivity. You can configure it for your home Wi-Fi. Then you can connect it. All right. So any questions so far? Okay. Hope is clear, Dr. Muhammad Azmat. All right. Okay. So, okay. Okay. Now let's go on to the next one. All right. So different hardware platform. Let's see the different hardware platform now. Okay. So now I want to just very briefly different hardware platforms. This is the Raspberry Pi 4, the new one. Most of you know that Raspberry Pi 4 has got a very powerful. So ARM Cortex A72, memory 8 GB. Then it has got a clock of 1.5 gigahertz, connections, Wi-Fi, Ethernet, and this one. So I'll also show some boards here. Hopefully I should have all the boards. So you have, yeah, this is the Raspberry Pi 4 older version. I also have the Raspberry Pi 4 somewhere. So I was just doing an example there. So this is the, okay, this is, hope my video is also clear, sir. My video and the slides are visible, sir. Dr. Garg?
Yes, sir. It's visible, sir.
Okay. Visible. Okay, thank you. So let me just. So this is the one, the Raspberry Pi for how it looks like. So as you can see that there are different slots, memory slots here. I had a Raspberry Pi 4, but anyway, this is all different slots, and we have a VGA, SDMI connector. Then it has a memory, which you can, I think most of you know that it's up to 32 GB. The new one can go, can insert. And then you have got a 40-pin header pin here, right? You can connect it. So this is a simple computer board, which doesn't have a keyboard, mouse, and monitor, right? So you connect from external through this USB port and make this as a computer. And now this chip, there is a small chip here. So this is the memory SD card. So you can load your operating systems and some of the software what you need. Database, if you have database, heavy database, you can load it, and then you can make it, and then you have the Python libraries onto that, and you can up and running in some of the applications on that. Okay, this is one board, and we have this is an Arduino board. Most of you know that. I don't have to go through that. It has got both analog and digital port. So this has got only digital port. If you have analog port, you need to have an analog to digital converter there, right? Because it has got a GPI, general purpose input output devices. The reason why they kept it simple is they want to configure this board, whether you can configure as an input as an output. So whereas this Arduino, it has got both analog as well as the digital this thing, but it has got its own programming, right? It has got its own C programming, right? So it has got the, again, the processor wise, we have two companies, right? One is the ARM processor, another one is the Intel processor, right? So all the, most of the IoT hardware you see, they're all ARM enabled processor, you know. So processor, and then it has got the memory of 2 KB RAM. The new boards also is there now, no Wi-Fi. So these days we also have the with Wi-Fi connections here, right? So node MCU. So I should also have an board with, okay. So this one is, this is not a node MCU. This is an, you know, people ask me this, call the question. This is an Arduino board, which has basically, which has got the Bluetooth, or you can do different shield. You know, you have a Bluetooth, or you have Wi-Fi, or you have got a GPRS also, right? You can connect the GPRS. You can, I don't know if you can see, there is a slot here. They give the, you know, memory slot. Once you have the memory slot, it goes to the programming and then goes to the nearest LTE or the 4G center, and then you can connect it, right? So this is the smallest Arduino footprint for IoT, right? You can create an IoT and very simple programming. Of course, they have their own C programming. You have to learn that. And Node MCU, most of you know that Node MCU, I guess you are using it. So it has got the ESP8266, 128 KB of RAM, then 80 megahertz, and then the connection is the Wi-Fi connections here. And ARM embed, this is a very old, this one, basically when ARM introduced, you know, they had a board which doesn't have any outside Wi-Fi or Bluetooth, you know, they just had a Ethernet connection because they just want to make sure that all these devices, you know, you have here, you know, header, you have this, what is the joysticks, then you have RF model, then they had accelerometer, and everything they want to try it out, you know, first how it works. And later, slowly, they converted into, and you see temperature sensor is in hat here, 3-axis RGB LED. You know, let me just take the pen here so that you can understand. Laser pointer, okay. So you have the LED here, and then you have graphic LCD. Is actually embed application shield. You know, you can just put it on this board, and then, you know, you can create any kind of an application just to try the proof of concept, right? Yeah. So they had an ARM Cortex memory, 256 KB RAM, then clock 120 megahertz, and then you have the connections of the Bluetooth and Ethernet, you know, 10 by 100, right? Yeah. Now the other processor, we have the Intel Edison, right? Intel had their own, you know, the process in the IoT hardware. So they actually came out with earlier versions, because Intel, as you know, they are very good at the server PCs, right? This one just to add to demonstrate their capabilities onto the IoT, right? So Intel had that, and you know, they had a again connections with the Bluetooth, clock 500 megahertz, very powerful you know, system there, right? Yeah. Then other popular boards is the Arduino Nano, then ESP32. I showed you that you know, Wi-Fi 1010. Then you know, and then the Wi-Fi. So there are so many processors are there, you know, 30 plus are there. This is a multifunction development kit what I showed you. So everything is glued together here, you know. You have a, like I said, you know, Arduino board, Raspberry Pi board, everything is glued here, and you get some sensors over here, you know, right? Yeah. So I see some questions here. Let me take some questions here. Any questions so far before we move on to the software world? So then we have a sensors and actuators, you know. So then, you know, one is, of course, you know, you have a, you know, the hardware. Then you also have the sensors and actuators, right? So like we talked about, right? We have a A to D converter, because if you want to connect it to a Raspberry Pi board or anything which accept the digital, so you need to have, you know, the A to D converter here, and then this is actually comes with the box, you know, whatever I showed you, it comes in the box, power supply and D to A converter, and then actuators, right? You have a 7-segment display or LCD display or some switch, right? You can switch or relay, right? You connect it to a motor, right? You want to connect output to a motor, then you have that also on this, right? Yeah. So this is actually, I know how the sensor it works. I mean, I'll share the slides, but I'll just skip, for the part of, the real discussions on that. Okay. So you have basically you have a transducers and then analog signal and secondary transducers and the final user block. Just take sensor is nothing but the variation in the voltage or variation in the capacitance or variation in the resistance, right? You take, for example, microphone is in another sensor, right? So you have microphone, and that microphone, what it does is converts the sound or the audio signal to the electrical signal, right? So what is happening inside, there is a capacitor, right? So when you talk, the capacitor is dielectric, what they call, not dielectric, it goes high and low, right? If it is high means one level, and as your plates come nearby, it's releasing, right? So that's how the signal is analyzed. It's a sinusoidal signal. Now I need to convert them into a discrete DC component, right? Because remember, all this microcontroller, all these things, they accept only the zeros and one. No? It doesn't understand anything analog. No? So when you have a temperature, we'll show it in the programming, in the Python. So we normally program it to this voltage, right? If it's a 3.3 volts or a 5 volt DC, then we program it to that level and that, right? Yeah. So these are some sample sensor, how it looks like. So you have the light sensors, then temperature and humidity, barometer, which measure the pressure, right? Now I know sometimes you have to measure your pressure, how much is the pressure coming in the field. And then the gas sensor, then temperature, air quality, then you have temperature and humidity, and then the HCHO sensor. Then you have again a temperature sensor. It looks like a transistor, right? I mean, those who are from electronics background, but it's a temperature sensor. Pulse oximeter, then ceiling mounted PIR sensor. This one is also in sensor. Sensor looks like this, right? So I was just doing some experiments. So this looks like this, right? This then proximity or the sensor. Then industrial fire smoke sensor, IR sensors, then your water sensor, pH, measuring the pH 4, right? So you want to check the pH 4, right, in the city. We did one project or one guest lecture in NIT Agartha, NIT Warangal. So there it was full about the water, right? Because they had a real problem with the water, right? Water is coming, but the quality, what is the pH? There are 60 plus qualifications, parameters you can check on the pH. And soil moisture, this is for the agriculture purpose, right? You want to monitor what is the moisture level of the soil. Based on that, you can pump in the water, right? Because you don't need water all the time, right? So there's an agriculture sensors are there. Then turbidity sensors, this is another environmental sensor. So there are so many sensors are there, you can always do it. And there are some actuators, right? LED is also an actuator, right? Just show the display to that. And you have a liquid crystal display. Then it has the buzzer, the 5 volt relay, stepper motor, water pump, right? You can pump the water. One example is that one of the experiment is that, in some of the places where, you actually pump the water to your tank, right? In the first floor or second floor or third floor, right? You pump the water from the ground, and then as soon as the tank is full, I think it's already come. So you can send a signal or message to your phone, right? Okay, now this tank is full, water is full. Now you can, stop it, right? I mean, somebody can switch off the pump, right? Somebody switch off the pump, which is taking the water from the ground level to the third floor or whatever. Vibrator, DC electric wall, all these things are the actuators here. So now let's go on to the cloud. This is about the hardware. Any questions so far on the hardware? I'll stop because I wanted it to be more interactive. If I keep talking, then probably I have hundreds of slides. We can always go through that, but I want even we are lagging, how we can do that. Yeah. So far, let me that. Yeah. Any questions, sir? Okay. So far, so good. Okay. All right. So now let's go on to the software world, right? IoT introductions, block diagram, hardware, different hardware component. Again, these are all the evaluation board. If you really want to build an IoT, what you do first, you check your IoT projects onto this board, and then you go on to the manufacturing. I want to create a system on chip. Can you please help me to get this? Then you go to system on chip company. They provide you a system on chip and make it, right? If you go to the any temperature monitoring, we are not going to put this, right? You just put a very small, tiny board, maybe size of a coin, one coin, a dollar coin. Then you put inside, the your battery, then your sensor, then a small microcontroller processor, and then connect it to the Zigbee or Bluetooth, right? And then it transmits the data, right? Yeah. All right. So now let's go on to the hardware model here. What are the software model we have, right? Yeah. All right. So now before that, what is that cloud computing, right? I think just I taken some background. What is the cloud computing here? So in addition, the platform provides so basically it provides the demand services. One thing is that you have to scale up, up or down. Scale up is definitely required, because remember that we talked about that billions of devices are connected to the cloud. Now we need to be in a position to configure those devices, right? So that's definitely scaling up is there. Hardware and software are available to general public, enterprise corp. Yeah, even the cloud, you can make it to the general availability. You can make it customized only to your university or your campus, or you can open to the public, or you can make it a SAME, right? I mean, only you can pass on the information what is required to the public, and you can keep it yourself. So those are the advantages when you have the information in the cloud. So common characteristic, massive scale. We talked about the homogeneity. Basically, you need to be able to scale it up or scale it down. Virtualization, yes, you have to reach cloud characteristic virtualization, right? Because see, for example, the platform whatever I shown, now remotely I can connect it, right, through a VNC. There's nothing but a cloud software on it, right? There's a VNC software in the cloud server, there's a VNC server in the client, and then both of them they're talking, right? So virtualization, low cost software, yes, the cost has to be low. Then resilient computing, right? So resilient computing is that it should basically keep on computing the data when there are so much of input is coming up. It should be able to compute. But IoT, I won't expect them to really do it in a device part. But in the cloud side, they have got a lot of levels on that. Geographic distribution, yeah, it has to be distributed. This thing. Another thing I would add is the redundancy, right? You need to connect it. Suppose one thing is failed. Now, how do we pass it that information to the next one, right? That's why if you really see the cloud, whatever you have got, whether Amazon, Microsoft, whatever cloud you use it, they will have multiple connections there. No, for example, one server may be in San Jose, one server may be in Seattle, one server may be in Boston, one server may be in Delhi, or one in Bangalore or in Agra. Anywhere it can be there, but everything will be, all the server will be doing the same. What happened is if some server fail, it automatically the second one should be able to take it, right? Third one should be able to take it. For example, God forbid, and it should not happen. If something happened here, we had a challenge here, because 4 weeks back we had a this wildfire, right? All the forest got burnt in Sonoma State University. It's everything was burnt on the upper side of the north of San Francisco. Now this year server didn't burn, but in some time it burnt last 2 years back. It has a similar problem. Everything burnt. It doesn't mean that we are keeping one in one, right? We kept it on the other side, so it will always transfer the data from there, right? So let's see. I see some questions here. That is good. Or I don't know. Let's see here. Let's see anything question here. Okay, no questions so far. Okay. So let's continue that. Okay, so now so this is the different services we have got, basically, information as service, platform as service, software as service, right? So you have different this thing, but you can name it private cloud, community cloud, public cloud. So I won't go there, but you can create a cloud in just a matter of 2 days. As long as you have good server and a good connectivity, you can create that. Now let's go on to what are the different cloud platforms, IoT cloud platforms. So you have a ThinkSpeak. I think many of you know that ThinkSpeak. I'm pretty sure, if you're doing an IoT at the university or academia level or research level, you know the ThinkSpeak. UBA Dots is another company which is based in Europe. They provide you some, free services. Amazon Web Services, Microsoft Azure, Extrans Cloud. So we also created the cloud along with this so that university can make use of it. There's no cost to that. You can log in and then we maintain your or we help you to connect it to the this one. So let's go on to the ThinkSpeak, right? So you have a ThinkSpeak cloud. So it has those, if you are familiar with the MATLAB and Simulink, is a part of MATLAB. The ThinkSpeak is from the MATLAB as MATLAB. So it has the Simulink and the MathWorks. It combined, and then the good visual display data. Yes, it is a good display data. You will be seeing that. We will be showing some demonstration here, and I would recommend, whatever time we have been given, feel free to do some lab, from your example. You want to do any, say for example, create some, if you have sensor, that is fine. Otherwise, at least you ask the instructor, my colleagues there, okay, now I want to connect it to the, one of your temperature sensor. You can log in remotely, and you can able to log this. So I would recommend that if time permitted. Read the data from sensor and processing activity. 3 years free service. This is very good, right? People ask me that whether it's a paid, nothing. It's a 3 years of free service, and it has got the mail and Twitter, right? You can connect that to a Twitter, right? For example, I'll just again give an example, temperature or pollution or anything. You want to tweet that message, okay, hey, this is the tweet, this is what is, you can automatically create that, subject to that, flexible and then easy integration using the API, and then 3 million free transaction per year is possible, and best cloud and academic research on the student. That's true. Yeah. So this is how the ThinkSpeak it works. Basically you have this is the the steps involved is that I'm a developer here. So what I do is that I'm a developer here. I registered the ThinkSpeak account. I would recommend everybody to log into ThinkSpeak and create your own account. ThinkSpeak is a free account. You can create it. It's an IoT cloud platform. ThinkSpeak, you register the device and create a channel and record the identifier keys here. Actually, it'll ask you to enter your name, last name, then your university and all. So then you configure your devices, right? But in that, you get some kind of a keys here. This is your, send message channel and keys here. So you get some kind of an configure it. Here we shown has a temperature meter, right? We are configuring it. Unconfigured thermostat and send data to the ThinkSpeak, right? You configure it, and then on your board, this is on the Arduino board we shown. You can connect any board. So you configure it and send that data to that, and then so one more thing is that they will send you. We will try to log in. Otherwise, in the lab, will show you that. So you will get in some kind of an API. So as long as you connect the ThinkSpeak, it's like if you're coming from a computer science background, you know that, right? How you can connect the data to the any database. You download it in the cloud. It could be JSON database or it could be any Oracle database. Similarly, ThinkSpeak will send you the API. Just integrate that API into your Python code or your Java code or embedded C code, and then configure your device, right? See, this kind of a board is a Marvel board, right? I didn't show it in my presentation. They actually very strong believer in the embedded C, right? Everything is programmed in the embedded C, right? Yeah. So here it is, this is an SoC, which is basically system on chip, and it's got a microcontroller, and then you have Wi-Fi chipset here, and then they have some switches and buttons over here, right? You can use it to configure, but everything they did is, and this is very tightly coupled to the Amazon Web Services. They have some collaborations. You don't need to, but nowadays almost all cloud companies, they are giving you the connections, because they want their cloud to be used, right? They invested so much, like Microsoft, right? We used to, I remember that I used to spend months to get a right person. How do we connect to the gateway? Nowadays it is free. You can just connect it to their IoT, whatever the hub or IoT gateway, and then you get connected to their device, and ultimately you want to connect to a Power BI. It's a Power Business Intelligence. You can connect to the Power Business Intelligence to that, right? Yeah. Okay. So then AWS cloud. This is another one. AWS cloud has becoming very powerful now. So it is the top most commercial cloud, 175 cloud services. Just imagine that, they have 175 cloud device services. I think we might have used hardly 10 or 15. You can use several of them in that. Then it has got an IoT core, is a service provided by AWS, and fully secured. It is fully secured, yes, for sure, because in King Speaks you get probably 1 or 2 lines, but in the AWS you get really full bunch of the data there. So then 1 year free tier to use all services, allows you to send alert through email and then pay as you go. Once you finish your trial, then you can, analytics is there. So it has got data and machine learning algorithm. This is very important. Remember, we talked about in my second slide, right? We have machine learning algorithms from the IoT, and broad connected category of services for visualizations, AI and ML, big data. So yes, that is definitely possible. It is actually meant to be for artificial intelligence and that kind of data. You take any temperature data and convert them into real requirement. So this is some kind of an pictorial diagram, what it has got. Most of the companies will have that. They have got an IoT services, then it has got an IOWS, IoT, rule engine. There is a rule engine. So rule engine means, suppose, my temperature go to certain level. Again, I'm giving an example, don't get me wrong, but I just want to, okay, my pollution of this particular, my city is, a certain level. Now I need to send and message to the city pollution officer or whoever is that, they can always get a message that, okay, this particular pollution is going up. Now I do that. Or a temperature sensor, right? A temperature, you can set those rules, email, text message, automatically it will send. When you set certain limit, while that condition, what we call it in the programming language, right? While at this condition, you send that message, right? Or at this conditions, or for these conditions, you just trigger that messaging, right? So then it has got, Amazon has got many services. You can utilize those services. Of course, MQTT messaging, when we go to the software, this thing, we talk about MQTT messages. Then it has got the different analytics, and you can show the different visualization. And good thing is Amazon Quick Light, so Quick Light has got several, the opportunities and several facilities. You can push the data and use the quick site, so that's very good tool. It's again, everything is visualization. You come with a very nice graph, but you can really chunk the data. You can get the output whatever way you want it, right? See, X and Y coordinate is one. That X and Y coordinate, you can multiply it to different dimension what you're looking for, that, right? Yeah. So this is another next pictorial diagram. So you have a certificate. It's very important. You get a certificate, IoT certificate and IoT policies. So you can define the IoT, whatever the policies you're looking for it. And then cognito identity, So cognito identity is that it will store some, the predefined configurations, and whenever you load it, then it will get the data to that particular this aspect, right? So then you have a AWS user, and then rule engine we talked about. The DynamoDB, you know, this is in another Dynamo database. If you are familiar, you can integrate with easily with your IoT. Then you have the Lambda functions. You have the Kinesis. Lambda function is, you know that, you know, you can integrate any special function into your IoT devices or take it from the cloud and push the data to the Lambda functions. You know, right? So these are the some details. You know, probably, you know, you can. I'll share the screen. You can go through this. So you have AWS IoT, then analytics, a quick site lets you easily create and publish interactive dashboard. That includes machine learning inside dashboards can then be accessed from anywhere and embedded into your applications, portals, and websites. You know? So so this is our friend Microsoft Azure. So this is also, you know, very upcoming one. So now it is become more open source. You know, you can you know, connect you know, to this gateway. So you have again, the different processes are there. Register the device here. One, let me just use the different pen here. So you have you are registering the device here. Any questions so far? Let me, before I go to this, you know, yeah. I see some question here. Oh, no question here. Okay. Okay. So I think let me continue here then. So this is in another one, Azure IoT. So you have, you know, so which is basically, you know, so you have, you know, register the device, then you have device itself here, and then sending the sensor data to the IoT hub. Then you read the data from, once you wrote it, this is you know, any smartphone, you can connect it here, and giving the IoT hub as input to the stream analytics. So you have a, you know, there's an analytic engine there, and then store the IoT data. See, it has got a storage, it has got analytics, and then it has got the, you know, using the, you can query, actually, you've got some, you know, your own database, and then you can query whatever you're looking for. And then good thing is Power BI, you know, I would highly recommend, you know, if you are, you know, computer science or computer science, Power BI is very, very powerful tool. You know, there was so much of combination there. You can connect it to the Power BI, you know, because earlier it was not there. Now they did with that. That's very good, right? You don't have to create any software or any required, you know, the power engine to that, and automatically it will take care of it. Yeah. So this is then another same thing. So we have, you know, IoT as devices, cloud gateway, data transmissions. So any cloud you take, one thing is there. One is that your input should be acceptable, which is MQTT or HTTP. And the second one is that your analyzation, include an analyzation, and then some actions. And of course, I'll add the output, right? We need to get the desired output, right? Any cloud, you get a, you know, visualizations, store the data, and then you can, you know, configure it. You can modify it, all this graphical, you know, suppose you need an XY coordinator or you got anything. So that's a good thing. So I would highly recommend, you know, you make use of our presence there. You log into there. Probably we may not have time to do the Azure or the AWS, but at least ThinkSpeak is there, right? ThinkSpeak is a very simple process. You know, you can I'll leave it to my colleagues, you know, what plan they have. But I would recommend, please, few of you can try to log in, you know, during a virtual lab and see how it looks like, you know, all the sensors. And also you can create your own cloud account, and you tell them that, okay, now I want to read the temperature sensor. Please show me that in on my cloud. You know? So you can see it on a ThinkSpeak, your own desktop, right? So this is an UBA. This is an, again, free services you get. If not free, it is the this thing about up to 3,000. That is also very good, same as any other one, but it is very simple to integrate it, right? Yeah. The difference between the AWS and the Microsoft is that you can take it up to the next artificial machine learning and artificial intelligence. Take that data, you can train the machine and then create the artificial intelligence model in that, right? Similarly, Google one, if you take, they have got a TensorFlow, you train the machine based on the data. And then of course, there's a different libraries they're creating. Sometimes you may have to create some special libraries to sense the data to that, right? Yeah. So Extrans, we also created a small cloud to the extra, just for academia purpose. It's not any commercial anything. It's free. You don't have to pay anything. So if you want to include that, our colleagues will, very briefly tell you that what it is. But if you want to have that, we have an alpha version. So you have an external cloud designed and implemented by Extran Solutions. So connect it to your devices, Extrans IoT Cloud. And you can, you don't have to have this board. You can always connect it, your own hardware. Any hardware you can bring it. We will be able to demonstrate and provide other things to you. Yeah. So these are some of the data shown in the Extrans Cloud. For example, see temperature sensor. You can modify all this, little UI. You can modify whatever way you want it. It's all flexible, and believe me, you can create your own cloud in 1 week time. You have a nice the server, high speed CPU, then good memory, good connectivity, and then good atmosphere, because it cannot be just outside the air condition, right? It has to be. If you have all these 4 or 5 aspects, you can create your own this thing. We did one in Santa Clara University. We have one IoT cloud, Santa Clara, and we connected all this hardware, like the Raspberry Pi, and we have this something like this is from the Samsung. Then we have, I didn't show about the ST microelectronics hardware. This is also an IoT hardware. And then we had, phone from even this is another Freescale board. So all this board we connected to that. In fact, one of the professor from Hyderabad, he visited us. We took him to that lab. So we connect all the hardware, and any student they come, they can do any research paper, any exercises they want to do that they can do it. Of course, they have to go through certain process. So they can release a paper. Okay, now I want to use I'm just giving an example, ST microelectronics. I want to use this. I want to publish a paper. So we made it very easy for them. Okay, you go there, you log in. This is the board available in the lab. Now we are giving them at the home. We are trying to make it a remote login. Like this board we made it, right? It's a remote login now. So this board, whatever I told you, will show that which has got a virtual network computing. You can log in remotely, but so you can do that. Okay. So, and yeah, before that, we also have, that is the cloud, and the first version of our IoT, how we started, I just want to share one more, the kit, how you can design, for your own purpose, right? So let me stop here. So basically it was something like this, right? This is the company from the Dew Mobility where we created that. So it has got the gas sensor, then barometer, and then the temperature sensor. Then you have the temperature and humidity, then light sensor, barometer, and the gas sensor. And this is the air quality sensor, right? So everything is programmed using a Marvel board, right? It was Marvel because they were sponsored some boards to the university. So it was something like this, right? So we used to have, all the connectors, you might see that all the octopus kind of a wire. So here, all your hardware sits here and all the sensors. And then, you program it, we use their embedded C programming. And then, you connect it through an Wi-Fi here, right? So there is a Wi-Fi chip here. So we used to program it like somebody asked the question, right? How can I connect it? So as long as the Wi-Fi here, and you go to the cloud, and then you push the data to the cloud, and you open up your device. And remember, this was connected to the AWS. So they send you the certificate, and then we have to integrate. They call it the flash memory, right? You have to flash that whole code there, and then you make it different. So this is another one you can think of it, your own IoT box, because only we need, and this one, we just assembled at the this one, but we wanted to make it a little. Why we make like this is, see, student, when you go any of the project, what happened, you give the discrete component like this, and then discrete component like this, then it is tough for them, right? So that's why we said, okay, let's go and build everything together, and we give them a consolidated thing. This, instead of giving this one like this, it's, you give them a complete assembled board. So those are my the IoT. We talked about the block diagram. We talked about the the sensor different components, and then we also talked about the what are the different cloud components. So probably follow-on session, we talked about the protocols, how to connect, and then we have a lab, virtual lab. And I probably, if time permits, I will come back on the smart cities, because I wanted it to be in the morning. As you see that now it is already 12:15 in the night. So beyond that, it will be a little, I mean, I can go, but I may not be that much efficient, because there is some kind of a tendency that, I might miss some of things. So if I get an opportunity to before 11:30, I'll be happy to share. Otherwise, my colleagues, they're also equally qualified, capable, they can share some of the smart city application, what we have done here. They already been with me for last 3 years. They'll be able to do that. So with that, I will stop here and take questions. So there's one question, it done in the cloud itself. Then what's the need of processing is? There's a good question. Processing is not done in the cloud, sir. Actually, processing means, see, there are two kind of processing, right? One is you have to basically, microcontroller has to identify the device, and then it has to it's really not computing much of a data. Okay, I'm taking the voltage from my sensor, and then maybe compute it a very very at a less level, and then produce that data. So what the processing at the cloud helps is, suppose you want to display result, right? You want to do an X and Y coordinates, a raster diagram, or you want to do a pie chart, pie diagram. So that time, this cannot do, the microcontroller cannot generate those X and Y coordinates, or pie or raster diagram, right? You need to have some cloud which can really process, and we don't need a high processing at all, So mainly microcontroller, whatever you're using, I2C or UART, it goes there. There is a timer, basically it's a watchdog or something like that. It produces your stream of signal, and in that signal is kind of an handshaking, right? Okay, one sensor, that's fine. If you have more than one, right? Now use the data. I am ready. Okay, I have whatever I am supposed to do, that voltage program based on the program, and convert it and send it. I am ready. Now I can take the next one, right? It's an IO operation, right? So it's not doing much of any heavy processing on that. Everything you can push that data to the cloud, for your visualization data, right? See, even in the desktop also you can see that reading, right? You can go to that reading and see that, okay, what is my sensor data, what is my pollution data, and all these things. But if you want to really have a big visualization, the good thing is, once you have the cloud, you can put the data anywhere into the cloud. Yeah. Hope that answers questions, sir. Yeah. I think we are coming to a fag end of the time here. I don't want to take the time for other speaker. I know you have got line of program. Any other question? All right. Yeah. If you, how gateway provide connect, that's a way. So if you don't have any question going once, twice. All right. Okay. No questions. So over to you, Dr. Garg. Yeah.
So thank you very much, sir, for giving a brief about IoT. A very well discussion on introduction, then block diagram. After that, hardware, and then real demonstration of hardware and sensors, and then you have very well explained cloud computing related to IoT. So thank you very much, sir, for your amazing lecture. Thank you very much, sir.
Thank you so much. Have a great day. Thank you all. Yeah.
So all the candidates, all the participants, we will again meet at 2 for the next session. That is going to be a very interesting one like this one. So the next topic, next session is on IoT hardware and software protocols from 2 p.m. onwards. So kindly connect at that time. So till then, you may leave the meeting. So thank you very much, all the participants. Thank you.